Alrighty, so we are back and looking at a new chapter, chapter 2. So we'll start looking at 2.1, which gets into specifically quadratic functions and their graphs. So the first thing we can say is that when we have the graph of a quadratic function, we know that that's a specific type of polynomial function. So quadratic functions are a specific polynomial function. So what is a polynomial function? So we have the definition of a polynomial function. So we got n be a non-negative integer and let a sub n minus 1, all the way down to a sub 0. So again, that's why it's non-negative, because 0 is neither positive nor negative. And we want to have all of those be real numbers with a sub n not equal to 0. So we do want to have a constant value in our polynomial function. So here we have our general format. So with each of those a sub n's and a sub derivatives, so along with those are the corresponding x to the n power. So we have a sub n, x to the n power, a sub n minus 1, x to the n minus 1 power, and so on down the line. And so that would be a general polynomial function of x with degree n. So again, the highest power of the polynomial is the degree of the polynomial. And we're going to come back to that and talk more about that later on. So if we're looking at just a quadratic function, which we kind of should know in the back of our mind, that's going to have an exponent of 2. So we can be less fancy than having all of these a sub n's and all these subscripts in here, and just use 3 letters, a, b, and c. So our highest power is x to the second power, so that's our degree, and we know that then it is a quadratic function. So we have our definition. So now what can we say about a quadratic function? Now we already know a little bit about how it's a parabola, which that's our general shape. It's a parabola. But we have 3 essential characteristics of any quadratic function. And those 3 things are the vertex. So where does it, start to change its direction? And it might be a right side up parabola, but it might be upside down as well. So wherever that vertex is, where does it start to change? That's an important point to know. So we need that. We need the axis of symmetry. So with any parabola, if it's right side up or upside down, we know that it's going to have some vertical line where we can basically fold it in half. So that's our axis of symmetry. And then the orientation, which we've already talked about, it's either going to be opening up, where it's right side up, or it's going to be upside down, so it opens down. So how do we get information about those 3 things based on a function? So now we just described all of those different things, so we got all those things already defined, so we can just jump right into the examples. So the one thing I will say though is, as far as the orientation, whether or not it opens up or opens down, is determined by the leading coefficient. So I'll talk more about that when we get into our examples. So looking at our first parabola, not very fancy, but where is its vertex? Now, try to think of it in terms of what we did with the lines and with the translations and all that stuff. That'll kind of fall in line with these examples as well. So if we're not shifting it up or we're not shifting it to the right or to the left, then the vertex is going to be at 0, 0. So we know where the vertex is. The vertex is at 0, 0. Now, if the vertex is at 0, 0, then we know that we can fold it right on the y-axis. So what's the equation of that axis of symmetry? And again, I'm just going to abbreviate AOS. So our axis of symmetry is a line, and it's a vertical line. And so when it's a vertical line, we should know that it's of the form x equals a number. And that number, in this case, is 0. So the vertex and the axis of symmetry are always going to be related in that fashion, and we're going to dive more into that as we go. And then the last thing we should know just by looking at it is that it opens up. So that's really what they want when they say describe the parabolas. They want to know about the vertex, they want to know about the axis of symmetry and its orientation. Does it open up or open down? So what about our next example? What can you tell me about the vertex? Well, hopefully you remember that this +2 at the end of the function is going to cause a vertical shift. So we know it's going to get shifted up. So if the vertex is normally at 0, 0 and it's shifted up 2 units, that means our vertex is now going to be 0, 2. But what about the axis of symmetry? So what is x going to equal for our axis of symmetry? Again, we're folding it on a vertical line. But if we don't move it left or right, does it really change? No. So in this case, x equals 0 is still the axis of symmetry, and just by looking at it, we can kind of see that this also opens up. All right, let's try a couple more. So we got y equals negative parentheses x plus 3 squared. Now, you might think, well, I'm going to have to multiply that out. I got to kind of look at the whole thing, not like that. And that's actually not the best way to analyze this graph. When it's of this format, we can analyze and we can notice that it has a horizontal shift because of this +3 modifying the value of x. So we said that before. When it modifies the value of x, it's a horizontal shift. If it modifies the entire function, then it's a vertical shift. So in this case, we know it's a horizontal shift. And just be careful that you go the right direction. Which way is this moving? To the left or to the right? And hopefully you're saying left. Remember that sign, that +3, is opposite what you would normally think. It's going to go to the left. So we should end up at -3, 0 for our vertex. So what happens to the axis of symmetry now? Well, if the vertex is moving to the left, the axis of symmetry, is also moving to the left. So that should mean we get x equals -3. And then finally, does this open up or open down? Well, that negative all the way out in front is causing a reflection in the x-axis. So it actually is going to be opening down. And we're going to summarize all these things on the next page, so just bear with me. One more. So what about this one? What can you tell me about the vertex? Starting to see the pattern a little bit, hopefully. So we have a shift to the right 2 units, but then we have a shift up of 1 unit. So that must mean our vertex is going to become 2, 1. 2, 1. And so our axis of symmetry, I think you see it now, it's always based off of the x-coordinate of our vertex. So x equals 2 better be the vertex, and we can also see that this one opens down. Now the -2 in front does more to it. It's going to cause a stretching and all that good stuff, but we're not going to worry too much about that right now. We just want to get a general sense of these 3 features, these 3 characteristics of our quadratic function. So hopefully that makes sense. All right, so let's summarize this in the next video, and we'll continue from there. See you in a bit.